We want to find the point at which the line given by the parametric equations intersects the xz plane. The important thing to remember here is that the equation of the xz plane is y equals 0. Any point in the xz plane must have a y-coordinate of 0. And therefore, we can set y of t equal to 0, solve for t, and we can use that value of t to find the x and z coordinates of the point of intersection. But before we do this, let's take a look at the graph of the line and plane in space. Here we see the graph of the xz plane as well as the line given by the parametric equations. We're looking for the coordinates of this blue point here, the point of intersection of the line and the plane. And again, because this point is in the xz plane, the y-coordinate must be 0. So if we can find the value of t that makes this y-coordinate 0, we can find the x and z coordinates as well. So let's go ahead and find this point. Again, because the equation of the xz plane is y equals 0, at the point of intersection, we know y of t must equal 0, which means 0 must equal 4 plus 8t. So solving this for t, we would subtract 4 on both sides, and then divide by 8. This tells us that t must equal negative 1/2 at the point of intersection. So for our point of intersection, we'll have an x, y, and z coordinate, but we know the y-coordinate must be 0. So now we'll find x of negative 1/2 and z of negative 1/2 to find the x and z coordinates. So x of negative 1/2 would be equal to negative 3 plus 3 times negative 1/2, or 3 over 1 times negative 1/2, which would be equal to negative 3 over 1 plus negative 3/2, obtaining a common denominator of 2. Notice how we would have negative 6/2 plus negative 3/2, or negative 9/2. This would be the x-coordinate of the point of intersection. And now to find the z-coordinate, we need to find z of negative 1/2. So we would have negative 5 plus 7, or 7 over 1, times negative 1/2. So we'd have negative 5, or negative 5 over 1, plus here we'd have negative 7/2. Again, obtaining a common denominator of 2. Notice how this gives us negative 10/2 plus negative 7/2, or negative 17/2. So the z-coordinate is negative 17/2. This would be the point of intersection of the given line and the xz plane. So again, this point here is this blue point of intersection. I hope you found this helpful.